We had mentioned that there are two different types of sequences that we're going to discuss, arithmetic and geometric. In this video, we're going to talk about arithmetic sequences. Well, what are arithmetic sequences? They are a sequence in which each term differs from the previous term by a fixed number. Let's get the B-E-R in there, number. So each term differs from the previous by a fixed number. Well, what do we mean by differs? This is the key word here. Differs means that we are going to add or subtract from each term. Well, you might be thinking, well, differ, that means subtract. So how are we going to add or subtract? Well, we could be adding a negative number. If we add a negative number, that's going to be the same as subtracting. Or we could be subtracting a negative number. So that would be the same as adding. So in this definition, it's kind of a mathematician's way to write the least amount but still mean more things. So basically we're saying that differs means adding or subtracting. So how do we find the equation? Now we're going to actually find the equation for a sequence of numbers, and so we can determine any given number or any given placement of a term in that sequence. To do that, we have to start by looking at two different definitions. The first thing is called our common difference, and we use the letter D for that. Our common difference is the thing that we are adding or subtracting to the sequence. So anything that we add or subtract, which is going to be that fixed number, forgot my E here, that fixed number is going to be our common difference. And the thing that we're generally looking for is our nth term. So we're going to write u of n. Or u of n is going to be our nth term in the sequence. So this will make more sense in a moment. But if we know, as you've been working, if you have a sequence that is, let's say it's going 2, 4, 6, 8, and so on, we can see easily that each one you add 2 to the next number. So if we wanted to find the nth term, maybe we wanted to find the 7th term. So that would be u of 7. So at that point, n equals 7. So our nth term is our 7th term. Now something else we're going to use in here is called our n plus 1 term. And our n plus 1 term is just the next term. The next term. So in this case over here with the u of 7, our n plus 1 term is obviously going to be, if 7 is our n, then n plus 1 is 8. So we would be talking about the 8th term. Great. What does that all do for us? Well, as we start trying to look at some of these things that are a bit more complicated, a bit more technical, we might need to use this n and this n plus 1 term. So our common difference, and that's usually the thing that we might have to start by finding out what that common difference. Our common difference is going to be our n plus 1 term subtracted by our nth term. And that should make sense. If we look back over here at our 2, 4, 6, 8, if we take our 8, if we take the 8 and we subtract 6, so that's our n plus, this is our n plus 1 term, and we subtract our n term, maybe it's our 6, then we know our common difference is 2. We'll see a couple more examples with this, so hopefully that will get cleared up a little bit more. But our n plus 1 term is basically the term after our nth term. Okay, so how can we look at this to help us find actual an actual equation for our sequence? Well, I'm just going to rearrange this this equation here, and I'm going to add u of n to both sides. So if I add u of n to both sides, I'll end up with u of n plus 1 by itself, because a negative u of n plus a positive u of n equals 0. So u of n plus 1 equals u of n plus d. All right, great. That's still, it may look like it doesn't make much sense, but again, if we go back to our sequence that we had before, our 2, 4, 6, 8 sequence, so our n plus 1 term, so if we were focusing on n equals 3, so u of n plus 1 is going to be 3 plus 1, which is our fourth term, and that means it's going to be equal to our u of n, which is 6, and that's plus d, which we already determined was 2, so our u of fourth term is going to be 8. Hopefully that makes sense, because it does match up with our sequence over on the right. Now, we're going to try and determine an actual general formula for finding any given sequence, any given arithmetic sequence. We're going to go through a little bit of a proof here, but if you follow along, I'll try and color code it so it's easy for you to follow. We should be able to get through this. So, let's start with, let's get this out of the way so that way we've got a clean slate. We're looking, let me rewrite our u of n plus 1 equals u of n plus d. Okay, so let's say n equals 1. If n equals 1, then using this same formula over here, we're going to have u of 1 plus 1, which is u of 2. Let's just write that. I don't need to write the 1 plus 1. You guys know what 1 plus 1 is. U of 2 equals u of 1 plus d. Easy enough. If we say n equals 2, well, now this is going to be u of 3 equals u of 2 plus d, right? Because we're just taking the previous term, which is our u of 2. We're taking our previous term and we're adding d to it. But we're trying to figure out a generalization that we can use for everything. So since u of 2 also equals u of 1 plus d, I'm going to substitute that in for this u of 2 right here. So now my u of 3 is going to be from the green up above, we'll put it in green, u of 1 plus d, and then that's going to be added to d. So all I did was substitute, just like we did in composite functions, all I did was substitute this u of 1 plus d into u of 2. And now when I simplify this, I can say u of 3 is the same thing as u of 1 plus 2d. So I've got two d's there. All right, where am I going with this? Let's see one more of these, and then we'll see if we can make a generalization. So we've got n equaling 3 now. So n equals 3. N equals 3, that means we're going to have u of 4 equals, what we said before was u of 3 plus d. U of 3 plus d. So the previous term, u of 3 plus our common difference. Well, just like we did before, we said, well, u of 3 equals this. So I'm going to substitute this in right here for my u of 3. So now I'm going to get u of 4 equaling u of 1 plus 2d. I probably should have done that in blue. But u of 1, let's do that just to be consistent. U of 1 plus 2d, and then we're going to add d to it, plus d. So that gives us a new, we can rephrase this as u of 1 plus 3d. Now, as you're looking at this, you might see a pattern. What is that pattern that you're seeing? Well, if we're talking about this down here, let's just remember this is the u of fourth term, and this was the u of third term. So I'm just going to put these in here so we can see these things next to each other. So here we've got our fourth term. We've got our fourth term, and we're using our first term, which we've used in every single equation before that. So that's u of 3. We've used it in every single equation before that. And we've got this number here. Well, what's the relationship of 3 to 4? What's the relationship of 2 to 3? Obviously, that's going to be n minus 1. So once we start coming up with a general equation for this whole thing, we can say that u of n plus 1 is the same thing. Sorry, let me take this. What we're going to say is we're going to actually change this to u of n equals u of 1 plus n minus 1 times d. Well, you're probably thinking, well, wait a minute, before we were working on u of n plus 1. Now we're talking about u of n. How did that switch? Well, if we take it back and look at our example, if we're talking about the fourth term over here, we're talking about our fourth term, instead of talking about the n plus 1 term, if we just talk straight up about the fourth term, that's still going to give us the proper term using this formula, even though we've kind of lost that n plus 1. Because when we start including the n minus 1 here, it kind of takes into account changing it from the u of n to the u of n plus 1 to n minus 1 times d. I know it's kind of confusing, but really what I wanted to do is I wanted to get us down to this point right here, because this is a formula that you're going to use, and you'll see as you start using it how easily this works. So what we're getting out of this, what do we really need to know is that we've got, what do we have? We've got u of n equaling u of 1 plus n minus 1 times d. And if we want to find d, we can always say that's going to be u of n plus 1 minus u of n. So we're going to be seeing a lot of different scenarios as we work through our problems, and as we work through them, you'll have different values that you can plug in and solve, and you'll see that you're going to be using both of these equations quite a bit. So that's it for this video, and we'll see you on the next one when we go into geometric sequences. Whoops. There we go.